Let's get started. Again, good morning, good afternoon, everyone. Welcome to this webinar. So, can AI make software testing better, faster, and smarter? This is the essential question we want to address today. Along the way, we may want to make the case for why this type of testing is essential. So again, this is the first of many upcoming conversations on these topics, and I hope you'll continue to join us. My name is Ravi Sundaram, and I'm responsible for strategy at Quinnox. Quinnox is a Chicago-based information technology and services firm. And about 4 years ago, we took 20 plus years of client solutions and other experiences, and we started building platforms. And we started building platforms to solve some very specific digital challenges. Qyrus is one of these platforms, and it focuses on software testing in the age of digital. Today, I'm joined by my friend Diego, who's a renowned analyst from Forrester. He's been with Forrester since 2005, where he advises application development and delivery professionals. Diego is an expert on SDLC processes and practices. He covers everything from agile development, lean transformations, sourcing strategies, testing practices, DevOps, and quality. And he also has a critical focus on systems of engagement. Over the years, Diego has published various research reports. These include topics like open source, software reuse, semantic web, and object technology. He's also written an AI book called Practical Experience in Building Expert Systems. So again, it's a pleasure and honor to have him today, and I hope the audience gets the insights that they're looking for from his wisdom. The format for our webinar today is simple. Diego will share his views for the first 25 minutes. He will cover trends, common use cases, and opportunities in testing, and especially in AI testing. Following that, I'll share a couple of examples of how we're implementing AI to aid software testing. And we'll take some questions towards the end of the conversation. And for the audience members who have questions, we request that you post them on chat so that we can get to as many as we can during this conversation or subsequently. And with that, Diego, I want to turn this over to you. If you could please get us started on all current and the expected trends in testing and AI.
Thank you very much, Ravi. So I think if you can make me a presenter, I can load the slides. Good afternoon, good morning, everybody. It's a pleasure for me to be on this webinar. I want to thank Quinnox for inviting me and giving me the chance to share some of the research, especially that I've done in the testing space. I've actually been working in the area of testing for quite some time now in Forrester, leading the agenda there. And in the last 3 years, I started in 2018 looking at the intersection between AI and testing, both sides of the coin, as I say. One is using AI infused into testing, so to improve the way we test today, the traditional software we built. But there's also the other interesting side of the coin, as I say, which is use testing to test AI. But that's a different topic for another webinar, perhaps. But I just wanted to kind of mention that. So, all right, well, let me get started here and let's kick it off. I've got 25 minutes. So I'm going to run through some slides with you. Just a little bit of context. Of course, it's hard to start any presentation these days to talk about the context we're in, which is the COVID. And this is just one way of saying it. I've seen many ways of that refer to digital and that people, with the pandemic, our clients have done much more than what they used to do before the pandemic during the pandemic. And this is the president of Infosys that said 10 years of digital, and some clients have done 10 years of digital in 10 weeks. I guess it's a little aggressive, but Satya Nadella, the CEO of Microsoft, that billed last year to all the developers he said, I've seen 2 months, this was May, so we were in the pandemic for about 3-4 months, and he already announced the fact that he saw 2 months of digital. So in 2 months of the pandemic, he saw the equivalent of 2 years of digital. That's to say that really digital has accelerated with the pandemic, and we already had predictions for 2021, of course, created during the pandemic, and we've seen numbers behind just besides what I just told you qualitatively and what we hear word of mouth. There are data shows that really the investments in digital and especially in automation has increased tremendously. And the technologies that we see growing fast is, of course, cloud adoption. There's lots of migration happening, moving applications to the cloud, which is also bringing a lot of work in the testing space, by the way. And at the same time, of course, AI in general, the growth of AI, in adoption of AI from clients is growing. That's for building business applications, of course. Our data shows that about 73% of our clients, of clients worldwide, are adopting some form of AI in their organization. And there's always more and more a growing need for more software to be delivered and applications to be delivered. So the demand is increasing. This puts a lot of pressure, of course, on the development teams and the testers to deliver fast, and to deliver not just fast, I say, because that's what everybody likes to talk about, because they kind of give it, they kind of give it, by default that it has to be good working software. But I think that's a mistake, because quality is a first class citizen, and it has to be spelled out. So I like talking about delivering better software fast, right? It's better and fast, and not just fast. And unfortunately, though, of course, complexity is growing, because there's a huge amount of heterogeneity out there: cloud, non-cloud, and Kubernetes, and containers, and private cloud versus public cloud. On-premise, of course. Mainframe is not going away; it's still there. Mobile devices and mobile testing and browsers. The complexity is, is the heterogeneity of the platforms that clients are using. If you add on top of that platforms like now the business platforms like Salesforce and SAP and Oracle and so forth, right? And all the software that runs on these platforms, whether they're low level or high level or packaged, becomes harder to test. Now, on one side, there is, some people think that how do we make business more aware that they need to, we need to test, we need testing budget. As you will see, that's a problem, actually. Well, it's interesting. These are statements out of the 10K books of these very large companies, as you can, all of you might know, especially if you're in the US, from Walmart all the way to United Healthcare and CVS Health. But basically, they all have these statements around how damaging it would be for their business if they're, if they had quality problems. And although they don't spell it out clearly, calling them quality problems, they say if our products do not operate as intended, or business results and operations depend in part of the right information to be delivered to clients, or the technology-based systems give our customers the ability to do the proper shopping online. And if that didn't work, of course, it will, their business would be adversely affected. Guess what? They're talking about quality. They're talking about quality of the software. Now, testing does have challenges, right? This is, I don't want to depict, just a nice picture of, okay, so business is aware of testing. We're getting all the right funding. Let's just use the new technologies in the practices. Well, actually, there is still budget pressure when it comes to testing. This is data coming out from a specific consulting project we did, and budget pressure seemed to be one of the biggest challenges that clients complained about. The technology fragmentation I kind of touched on already. Access to test environments. This has been a traditional problem, and guess what? It's getting even harder. Although we've got now the technologies to make this easier, right? Let's say on the cloud and things to make it more easier self-service, but it's still a problem. Skills is another problem. Everybody wants to turn a developer into a tester, and guess what? Developers hate testing. On the other hand, the business testers or manual testers don't really know how to use the tools that offer automation and that need coding. So there's a shift of skills going in one direction towards becoming more developer oriented to be able to automate. But on the other hand, even the business testers and other testers that are less technical need to be able to use and test, from a business perspective. So that means also getting the right domain skills are important, banking, insurance, access to test data. This is kind of attached to the access of test environments. It's attached to that problem there. Normally they go hand in hand. TEM and TDM go hand in hand. But it's just saying even if I do automate everything, even if I do have very effective processes, if I don't have the right data that I'm using in that testing, it's going to be pretty useless, right? So getting access to the right data, whether it's creating that data synthetically or subsetting from the mainframe, from the production environment, and of course obfuscating it, that's a challenge. It's still a challenge. There's also a very fragmented market in terms of products and services. Every day I bump into new names and new companies, which makes it sometimes hard for clients to kind of navigate through the crowded market and find the right services and the right tools that they need to use. And despite we talk a lot about automation, well, automation yet hasn't really kind of, there hasn't been a breakthrough. There's been improvements. We are shifting from manual testing to automated testing. More or less it's increased. If we used to say, oh, not more than 10% or 15% of the test cases worldwide have been of testing has been automated worldwide. Well, maybe now we'll say 20-25%. That's still low. That's still very low, right? For agile and DevOps and continuous delivery, we need to get that to 80%. So these are all challenges that exist. And so the question is, what should we do to address these challenges? And really what I've been talking about, and I guess the industry has been talking about, is that we need to kind of modernize testing. And that doesn't mean just buying a service or buying a product. It means a bunch of new practices, and changing the way we organize our testers in the organization, in the teams. But also it is going to be, what's relevant is also the technology, right? The technology stack that we use. So it's really a complete change. It's a transformation, and it is also cultural, right? Just like Agile and DevOps are. And you can see that here. I'm just listing. This is a research I wrote, which I called and named the 12 must-dos for achieving continuous testing. That's what I named this modern testing about 5-6 years ago or more. I think it's not I think, I'm told, and I believe it. I was one of the first analysts to write about continuous testing as soon as DevOps started coming around in continuous delivery, right? It was pretty obvious to see that if people want to deliver continuously, you're going to have to test continuously as well. And these are the things you need to do to get there, right? It's about adopting some of those cool practices like test-driven development or behavior-driven development. It's shifting testing to the left, but also shifting it to the right. Testing in production. Think about the cloud-native applications. That's all happening on cloud. It's about chaos engineering. All these cool practices are actually starting to be adopted by some of the leading organizations that are trying to modernize their testing to catch up with the rest of the transformation that is going on. And of course, even the manual testing, it's not going to go away, but whatever remains of manual testing, it's going to be done in a different way. And the way that normally the practice that everybody kind of tries to use in replacing the old manual testing techniques is exploratory testing. There's a big change in the organization. Tester is no longer a siloed, first of all, it's not an artifact, but it's also not siloed in the corner of an organization, but testers are embedded inside the teams. That doesn't mean that test center disappears. It means that, yes, the test center with 500 testers will disappear, because probably you only have 30, 40 of them in the test center, because they play a completely different role. They help coordinate, orchestrate the automation, the tools, work with the vendors, provide specialized consulting of the testing. But the strategy, the plan, and the execution of the testing for a product, for a project, happens inside the team. So testing gets federated. That's how I call it. We get, of course, the metrics change. If you try to modernize testing, you want to measure if we're adopting the new activities, but also you start measuring automation, because you want to improve automation. You can't measure what you don't manage, and so therefore putting metrics around the improvements that you want to make in testing is going to be key. And then, of course, from a technology perspective, there is a big focus on automation, which brings, again, more practices and use of tools that we didn't really focus much on, integrating with CI/CD, using version control systems to be able to version control the automation and manage it, using API, more and more testing of API, because the applications are being more distributed and less siloed, web APIs, adopt some of these more interesting service virtualization for simulating complexity that you won't get access to. You don't always have access to the mainframe if you have an application that is like, a front end that is accessing data on the mainframe, and you want to do a complete end-to-end test. It might be expensive, so you kind of virtualize and simulate the existence of the mainframe there. Test data management I talked about, and then provisioning these test environments on cloud, self-service. These are just a quick peek into some of a quick summary. The report goes in detail on each one of those practices, and I know these are not all of them, by the way, but let's say some of the key ones. And guess what's happening? This is all being infused by AI. It's all being infused by AI in the practices and in the technology. So let's take a look at that. Well, before I do that, I just want to kind of emphasize a few things. The first thing is that if people thought that testing would be something that only developers would do, they're wrong. Testing takes a village. It takes these different personas. It takes a developer tester, a technical subject matter expert in testing, and a business tester. I named these Rodrigo, Chiara, and Carlo just to kind of have a little bit, more fun when I refer to these personas. But the point I'm trying to make is that, especially now, if you're building certain types of apps, you might need more of a Carlo on the as a tester, because maybe it's a technical application which doesn't have a lot of business and logic tied to it. But if it starts being more business exposed, that Carlo is not going to be enough. You're going to have maybe a technical subject matter tester. Actually, a technical subject matter tester will always be necessary on the team to make sure that the team has a good strategy around testing, but also because he can automate also using different type of tools that can be addressed. And the same happens with a business tester. Sorry, the business tester is Carlo, dev tester was Rodrigo. So you might have a business tester, because guess what? Business now is part of that team. Product owners are part of the team. You don't want them to do all the user testing at the end. You want them to do that sprint by sprint. So automate it, but there's a level of abstraction that can be imposed here, so that all three together collaborating with more or less involvement from each one of these roles, personas actually, being part of the testing of your teams, of your agile and squad teams. So so the question is then, is this enough? No, as I mentioned, really we have to also become more smarter about testing. I think we've been talking a lot about ruthless automation, right? Let's automate everything because compute machine doesn't cost that much. We've got lots of power. Let's just automate everything and run those execute all that testing. And really, that's not the case. It's not true, because automating tests costs. It costs designing them. It costs executing them. It costs maintaining them. And so the question is, can we become smarter about that automation? Can we become smarter in general about testing? Right? It's not just about increasing the speed of the automation. Actually, AI does little of that or less of that. It does more, optimizes. The opportunity we have is actually to optimize strategically the way we test. And so that's why we talk about AI in testing, right? The whole point of this research that I wrote in 2019 was everybody was talking about autonomous testing. I kind of defined a maturity, 5 steps to get to autonomous testing. But really the conclusion was, I don't think we're going to get to autonomous testing anytime close. Everybody talks about autonomous testing. There's a level of autonomy that we can bring into the testing, and it's thanks to AI. But still, we're going to have, testers and personas in the loop to execute the testing. And by the way, this is not just my thinking, right? Report 2000, I wrote that report in 2018. In 2020, the World Quality Report reached out for data, and the 1,700 respondents, 88% of them said AI is the strongest growth part of our test activities, which is both testing with AI, so in other words, using testing in AI, which is what we're talking about today, and testing of AI, which is how do we test those solutions that are being deployed used with AI? And they have a more optimistic number than we do. So the 73% I talked about a minute ago, which is 80% saying that more trials and proofs and concepts in place around using AI and adopting AI in 2020-21. So here's the way I look at the AI infused testing approach, and it's kind of aligned with the role of AI in general, right? There's a lot of writing about the fact that people might call AI augmented intelligence rather than artificial intelligence. Here I'm saying really that AI augments human intelligence. We wrote a general report that talks about how AI augments our human abilities and perhaps help us fail less in certain areas. And of course, it's clear that AI has some superhuman abilities that we don't have, right? We are not able to process all that amount of great data and find fantastic patterns outside of huge amounts of data that in lightning speed AI can do through machine learning. AI is used a lot for automating some standard processes with the goal of doing things, much more rapidly, much more consistently, and probably some of those boring tasks that we're called in doing. And then last but not least is AI, but where AI struggles, and that's where we are superhumans compared to AI, is AI struggles with uncertainty and judgment. It struggles when it has to create a context, and creativity, for example, right, is something that AI is not really good at. And so that's where we come in as humans, and where we can leverage the abilities of AI to increment the human intelligence. And so the question is, if that's what is happening with AI, can AI augment testers as well? And the answer is actually yes. And it can augment all these 3 personas: developers, technical, and business testers. Actually, it probably can augment more the technical and the business testers than it can on the developer testers. Research in the and the developers in general, helping developers build code with AI is ongoing, but it's still kind of behind where compared to how AI is being used for more business level applications. And in the testing, it's exactly the same thing. So basically, AI can abstract complexity to a point where it makes it easier for even the business and the technical testers to do things that might have required more technical complexity. And so in 2019, I came up with this list of use cases. And this is, again, as I said, a 2019 list. And I kind of classified them with talking about use cases that were mostly a reality because they had an ecosystem around them. There were either some system integrators using them with clients, a number of projects around the world, and consulting companies, and starting to see some of these use cases in product tools. And so they would become more of a reality versus mostly a myth, meaning that it wasn't that they weren't that mature, and maybe they weren't mature because AI wasn't that mature and still isn't that mature in certain areas. If you think about, natural language processing, for example. So these are the use cases where AI can help, for example, use high-level language and translate that into code for doing automated test generation. Visual testing, of course, AI is very, very strong in visual recognition, right? Being very precise, very fast, and introducing this concept of visual testing. Defect management and clustering. So in other words, being able, given all the bugs a big enterprise has, thousands and thousands of defects reported, kind of clustering all those defects into clusters that can be associated with a type of resolution that we know about and we know who can fix it, and therefore reducing mean time to repair. API test generation, being able to to generate APIs by running an application and generating and this is happening in some tools, generating all the API tests, the tests for the APIs beyond the user interface. Test lifecycle optimization, I think, is the most crucial. And actually, what's happened, and customer, and making even the design of the automation, the design of the test cases at the natural language processing level, all the way to unit test code generation, so forth. So these are kind of a quick brush of those. And what's happened in the last few years, there's been some additional use cases, interesting use cases that have been growing faster and become more mature. Many tools today would offer these self-healing of UI tests, right? So people complain that we don't automate because the test suites are fragile and they kind of break as soon as we change something. Well, most of those changes and most of those issues are due to the fact that the URL breaks, the locator breaks. And so using machine learning and learning much more, learning all about all the data and the properties of the user interface, we're capable, thanks to machine learning, to kind of self-heal and find maybe if something moved, what is the new locator? Where could that be? And actually avoid the system, the test suite to fail. But also using AI and machine learning to figure out, based on a change, which out of my huge battery of regression tests, which are the ones I need to execute? Which tests do I need to execute? Every time I check code in a CI/CD tool, which tests should I execute? Do I need to execute all of them? No, just the ones related to that really are affected by the change. And the last one is insights driven. This has become, test lifecycle optimization is becoming really important because we're using now all that data to figure out, what to test, what to automate, when to automate, actually not just what to automate, but when to automate and when to execute. So reducing the whole test life cycle. And so what's happening, and then there's this codeless, no code as well. You're seeing a lot of focus and emphasis on making testing easier for the so-called business personas and the technical testers. Oh, one more use case is in the test data management. I've seen people using actually some very advanced stuff here, using generative adversarial networks to be able to create data that is to create synthetic data that is almost indistinguishable from the real data, but it's not the real data. So therefore, you can really do some effective test data without, and without going through all the obfuscation process, knowing that you will be GDPR compliant. So AI is being used more and more in all of the test cases. So what's happening is, around this continuous testing loop, basically it's like having Carlo, Rodrigo, and Chiara working around this continuous testing loop with bots, right? With all those little, for each one of those use cases, it's like they have a bot that can help them get that testing done, right? Weaving through the defects and probably finding out who can fix a certain defect. Looking at the data in production and improving the user experience, maybe doing some visual testing for them with them, and so forth, right? So basically, testing takes a village, and now you have to add bots to the equation, to the personas that can do the testing. So I'm at the end of my 25 minutes, and I think that it's the real beginning, and actually it's more than just the beginning. I think we're already, in this freeway here, in this road towards smart testing, right? It's here. It's good to be used. I think it's not just about smart, it's also about making it easier. So I think we should all try and enjoy the ride. We need to do more testing. We need to do it better. We need to do it faster and smarter. And I think this is the great opportunity we have to for delivering software faster, and better software faster. And with that, I thank you and I hand it back.
So, Diego, thank you very much for that. I'm very, very sure that our audience found your insights extremely helpful. I mean, on a personal note for me, every time I listen to you, I leave the conversation having learned something. And of course, you already know that your ideas and your insights have influenced our product journey up to this point, and it'll continue to do so in the future. So again, thank you very much. For the audience, again, if you have any questions for Diego, please post them on the chat window, and we'll try to pick them up towards the end of this conversation. So in this section, I want to pick up on a few points that Diego made. First, he sort of discussed automation, testing, and quality in general. He spoke about AI. He spoke about bots. Again, he spoke about them both in general terms and some very specific use cases. But he also mentioned this term heterogeneity, the idea of different systems coming together to deliver value. And then he also spoke about different personas. So the different personas are an interesting challenge, and the concept of heterogeneity is also an interesting challenge, right? From our standpoint at Quinnox, the way we approach these problems is, and these are things that I'll talk about very briefly today. We look at emerging business models, and we look at different analyst notes on these topics. And one of the other terms that Diego uses is a concept called ecosystems. So we'll discuss that a little bit, because this is where we try to take the notion of heterogeneity, apply it to ecosystems, and then ask ourselves, how will this impact our clients, and therefore what should we do about that? And then the answer for some of these questions lies in our product. So I'll talk to you briefly about how Qyrus will or can impact some of these issues. And then finally, I want to take the concept of AI bots, again, something that Diego mentioned, and I want to briefly discuss two bots during this conversation. And then for me, again, the idea is to get into some sense of how these bots work, so that we can leave this conversation learning about how to use these bots, but what the pitfalls are, and also where the advantages lie. Right? But to begin this conversation, there's sort of this general question. In the future, there will be ecosystems. This is sort of a given. But the real question is this today's reality? So at least at Quinnox, we believe that there is this fast approaching business realignment, right? And this realignment will end up in ecosystems or some variant of things called ecosystems. And when this happens, and the argument, of course, is that it's already happening, this will be clearly an opportunity for some and perhaps a challenge for others. The question, or the second level question for us is, will this business realignment lead to exponential needs or requirements in software testing? Will this be an exponential testing challenge? And if that's the case, how do you prepare for that? So this sort of begs the question, what exactly is an ecosystem? I mean, how do you define it? And what are the popular definitions that are out there? So we took a look at McKinsey, and according to McKinsey, the world of ecosystems is really a customer-centric business model. So in this model, a single application or a super mobile app, it will be designed to meet every single conceivable business user need, again, within that ecosystem. But the idea is one app or a set of apps that are working tightly, integrated tightly together, they will solve all problems, all requirements, all challenges within that ecosystem. The idea is to create this end-to-end experience, which will span various products, it'll span services, and essentially everything that you need for an outcome, you will be able to obtain without having to leave the ecosystem. So what this in turn means is that industry lines will blur. Companies that are established today will have to compete with non-traditional players. Most established companies will have to compete with tech startups. So these new and sometimes diverse players, they'll bring different types of solutions, they'll bring emerging digital capabilities, and again, these digital capabilities will span multiple industries, at least industries as we've defined them today. So, I mean, to some degree, we're already seeing this happening in financial services, especially in the payment space where, the non-traditional tech firms are taking over the payment space, or at least competing head-to-head with the established players in the payment space. So this new environment will use data, that's a given. There'll be lots of interfaces. There will be a lot of AI, and more than likely, it'll involve a lot of regulatory reporting requirements as well. So in this new world, the word agility will have an even greater sense of urgency than it has today. Companies will have to constantly attack and carve out positions, and the idea of defending your customer base will be difficult and simultaneously mission critical. So this model that this McKinsey model that's illustrated on this slide essentially shows 12 different ecosystems that are emerging. They base this model on certain trends that they've already seen. And as an example, if you look at public services, which is 4.4 trillion, basically what you see there is even within the ecosystem between health and public services, those lines are beginning to blur. Right? So for our conversation, let's take a deeper look at mobility. Right? I've sort of highlighted mobility 2.0. 2.0 is the revenue. And mobility in this case really refers to the automotive sector. Right? So what you see in there is the size of the bubble for automotive and gasoline sales. So this continues, I mean, those two entities within the mobility ecosystem appears to dominate right now, and will continue to dominate for a period of time until, electric cars and others take over. But really, what we're trying to figure out with this slide, and as we move to the next slide, is the interconnectedness of each of these industries, of each of these clusters, and of each of these businesses. Right? So taking one step deeper into mobility, this end-to-end flow chart, it essentially captures the life cycle of car ownership. So in the bottom left-hand corner where it says search, it begins with researching vehicles or researching cars, searching for the right dealership, arriving at the right financial terms, all different things. But the reason they're all coded or colored differently is that right there, 3 different sectors will come into play to provide that integrated user experience for the customer. And as you move through this process flow, as you move through, from searching for a car or vehicle to acquiring one, to the maintenance process, perhaps using it in different ways, including rideshare models, etc. Collaborating with the car, this is really the rideshare model, and finally disposing the car or selling it. All of these processes, they're all tightly integrated, right? So the integrated, so the point that I'm trying to make is as you go through this life cycle, 6 different sectors will come into active play. Whether it's finance and service marketplace and government and insurance, there are 6 different marketplaces that'll come together to make this integrated customer experience happen. So how will this happen? More than likely, it'll be a super app or a couple of tightly integrated apps. So from our standpoint, this is sort of one of those defining moments where it offers definitive proof that industry borders are blurring, and that this new model is beginning to take over. Right? And if there's any question as to whether or not this is happening, whether these models will truly take shape in the way it's being projected, we looked at another piece of research, right? And this one, this picture, it essentially captures the evolving nature of the ecosystem for mobility. And what I mean by that is that between 2010 and 2017, $111 billion went into mobility startups. Mobility startups that deals with electrification or autonomous driving or connectivity, whether telematics or voice recognition, all these different things. This money went into 10 different clusters and over 1,000 companies. But we're talking about an astounding number here, $111 billion. But for us, from the standpoint of, what's going to happen to the future marketplace and how do we work in that future marketplace and how do we really test applications in that future marketplace, what this visual shows us is the interconnectedness of different things, whether it's leasing a car, whether it's fleet management and having to integrate that with a startup that's providing telematics and autonomous driving and energy storage. I mean, these lines between each of these clusters, I mean, that's what they indicate, that the tight integration between even these startups, right? So this is the fast-moving model that we're dealing with. So hopefully this brings some clarity to the question of, of where the markets are going. But the question really for us is, how do you effectively test a fast-moving, highly complex digital ecosystem? I mean, if $100 billion is going into startups and they're tightly integrated, I mean, that's a fast-moving market. Our answer is, it has to be AI augmented testing, and that's really the point that that Diego also made. So from our standpoint, we say that we need AI to test current and future digital models, especially as speed to market and frequency to market continue to become primary drivers. I mean, that's our position on this. So the question is, how do you do this? Our answer to this problem is our platform. We set out to build Qyrus, and our goal was to make testing easy. We wanted to make testing codeless. We want to make it integrated so that you could do all the things that I just showed you on the previous slide, deal with those challenges in an integrated manner. And we also wanted to make this platform available to multiple personas, because in that future model or that evolving model, different personas are going to have different responsibilities, and everybody will have a focus on quality. So an important objective is to create more testing, or this underlying objective is to create more testing, to create more to generate more training data, so that we can also feed AI capabilities. So our fundamental principle here is, if there's a way in which we could create a testing environment that enables easy testing, therefore more testing, which will lead to better training, which leads to better predictions, which leads to better coverage by agents, then it'll provide the time, the flexibility, and the much needed, I guess, time most of all for testers to do the creative work that they're best capable of doing. So our philosophy is, this is a process through which we're going to make testing better, faster, and smarter. Right? The content on the right-hand side is basically our storefront model, and essentially, as we speak, we take web, mobile, API modules to market, and in each of these areas we have different levels of capability. Web, to the point that Diego made, we have all the standard features like performance testing, functional testing, but more importantly, the self-healing capability. When it comes to mobility, again, we have all these capabilities along with autonomous testing, and we also run our own device farm so that we can provide that end-to-end testing experience for our clients so that they can test on real devices as well. And when it comes to API testing, again, everything is codeless, both for functional testing and performance testing. We also provide integration testing where you can chain APIs together, as well as service virtualization. But perhaps the most important point as far as today's conversation is this thing called component testing. So in component testing, explained in simple words, is basically omni-channel testing. Right? But if you think about the ecosystem model that's evolving or coming down the pike, the idea of testing across platforms, the idea of integrating tests that include web, mobile, and APIs across different platforms, across different systems, and making that work seamlessly, that's what the component module is designed to do. And to make all of these modules work well, we have a cluster of AI capabilities, and I'll talk to you about that briefly in a second. So the way we've looked at AI is, we looked at some of the things that have already been solved, for the most part, and we won't spend a lot of time on that today, right? So there's this capability of bots called Waldo and Hawkeye, and we have this functionality called Healer, but all of those things are in that visual object validation phase and in self-healing test phase. These are problems that have been solved. They've been around for a couple of years now. And off to the right is Sage, which is using AI to test AI, and that's a topic that we might pick up later with Diego. But for the moment, our topic are it's two specific bots. One is called Qyrus bot, which is essentially a conversational scripting bot, and the other one is Rover, which is an autonomous testing bot for all things mobile. Right? So the way our internal testing and AI product development evolved. I mean, the best way to sort of explain that is sort of the driverless car. I mean, going back to the automotive ecosystem example, I think it's best to compare it to the human driver and the driverless car. Right? And what I mean by that is, as you look at this picture at the bottom, as you progressively go up from manual testing to automation testing with some code and automation testing with Selenium and Appium, et cetera, we're at a point in the industry right now where there's conditional automation, which means that there is low code, no code platforms out there. We've solved that problem using Waldo and Healer and other bots. But where we're going today is at the next level of automation using the next level of AI. We're looking at high automation using the Qyrus bot, which I'll discuss in a minute, and full automation using the Rover bot, which I'll also discuss. So first of all, the Qyrus bot is essentially a conversational interface. It's a conversational testing system. The idea is it brings no code to the conversation or to the requirements. It's an Alexa or Siri type conversational capability for software automation testing. The primary goal is to get away from finding locators or identifiers when you have to build your script. Instead, the basic theme is you interact with the bot through a conversational interface or through text, and the bot takes care of building the script for you. And of course, you can save this subsequently and run it in any number of ways. Right? Now, where this becomes important is when you think about the complex digital system that I explained in the previous slide. Right? But bottom line, Qyrus bot is a conversational interface, and the idea is that even though it'll do a number of different things by itself, knowledge is still provided by the tester. I mean, that's a key part of this type of automation. But the net result is perhaps a new paradigm where we can skip that entire process of looking for locators and coding and things like that. Okay. So how does this work? Right. So I'm just going to play a little clip here. Okay, so that was a clip, and the idea is it's a very simple screen capture of a very basic mobile test, right? And but we just wanted to give you a sense of what we're talking about. The objective in this case was to find locator values and specifically verify if the right arrow on a mobile app is visible, and if it is visible, to tap on the right arrow. Right. Now, this is extremely simple, of course, but if you think about how you'd have to do this in a manual or automated fashion, you'd still have to go find the locators, you'll have to do a number of different things. All we did was we called in the information. We spoke to the bot and we said, can you verify that the right arrow exists? And if it exists, can you tap on it? And what it's done is it's done all that work. It's found the locator value for us, and the test has passed. Right? As simple as this is, it's relatively complex to build out, right? So how does this thing work, right? The Qyrus bot essentially has three main components. There's this thing called intent classification, there's data prediction, and then there's the process through which you arrive at element prediction and retrieval. Now, most of these things can work in a number of different ways, but the key things for us are the intent equates to the action classifier. Data prediction has two components, and we'll talk about at least one of them, entity recognizer and data fuzzer, which is basically creating data if you need to during the test. And then the element prediction and retrieval process has multiple subcomponents, rather, including predictor and matcher, and we'll talk about that briefly. But the basic logic is the following, right? If I take that very first screenshot where we logged into the app, the simple requirement here is that you want to enter an email in the email field, and it simply says admin@quinnox.com. That information has to find itself in the email field. Now, either through a voice or a text interface, the Qyrus bot will accept both. Once it has that information, it has to predict intent. And once it predicts intent, it has to set a certain action type. Now, for those of us who write code or those of you who write code to automate these things, you know exactly what I'm talking about. You now have to predict an action type here, right? So in this case, it happens to be set. So the intent classification equals action classification. And then, beneath all of this, what the team's done is they've trained transformers models to create that prediction and intention and action and all of those things that come together. Right? Now, the key takeaway from this is you've said something, the bot now has to understand what you've said, and it has to understand your intent. The next state of this is, once it has established intent, it now has to go into the application and figure out, what should I do with this intent? It has to identify this thing called the email label. It has to identify this thing called the data, and it has to make all of those things work together. So that's sort of the next phase of the algorithm, where it identifies the area or areas of interest for the user, and it also identifies what data should probably go into that particular position. The most interesting part is this next phase, where we start bringing all of these things together. Right? So in the element prediction and retrieval phase of the Qyrus bot, there are two key things. There's the element predictor itself, and then there's the element matcher. We typically use the element predictor if we have data in the system where you've already run these tests, and the bot or the AI can leverage existing data. In the situation where we don't have that, we typically go to element matcher, right? And this has 4 subcomponents. Again, in the interest of time, I'm just going to kind of blow through this, but the idea is, again, at this stage, all we're trying to do is enter email into a particular field. At this point in time, we have the intent. We've probably identified the area, which is the email label. We've probably identified the data that has to go in here, but all of these things could work in different sequences. So the next step here for us is to provide a screenshot, an image of the actual app. So at this point, the bot accepts the screenshot. It runs through what's called the page segmentation, where it searches through the screenshot, it parses the screenshot, it identifies locators, it identifies various properties, it will identify text and make that available. It then passes that information to the OCR, which takes the page segmentation output and converts whatever is text-based into the text that we can understand. And then one of the things that I said was to click on the right icon, right? So there's a separate library for icon tagging that'll identify this thing called the right arrow button, and then it'll make that happen. And all of this information is ultimately fed to the element retriever, where all of the intelligence starts coming together. So this is how the overall picture works. You provided an input. There's also input in the form of screenshot that happens automatically. There's also the page source, which happens automatically. The bot takes care of everything else. It takes care of classification, it takes care of entity data fuzzing, element prediction, and ultimately it feeds all this information into the Qyrus framework, and it creates this automatic test for you. Right? Now, obviously, this is a very tedious exercise to get to this point, at least in terms of explaining what we've pieced together. But the main idea is simply this. In this future world where you have to do a lot of testing, where different personas have to do different types of testing, you'll be able to go into a bot like this, speak to the bot, and you'll get the answers. Right? So in the interest of time, I'm going to quickly go through the next bot as well. So if the previous one was all about providing information to the bot and then letting the bot go find things, the next one is a bit more autonomous. Right? In this case, we're trying to address all the different challenges of mobile testing, whether it's frequent release cycles, that have to happen in short testing cycles, or the difficulty of validating all screens. There are a number of challenges that we face in mobile testing. And the Rover bot essentially, takes a basic file like an APK file. It'll take authentication information, and then it uses sort of this curiosity-driven methodology, reinforcement learning, basically, and it will generate tests for you without any human intervention. Right? So what that looks like is this complicated image that I have on the screen right now. Right? This is called a state transition diagram. Right? So essentially, what we've done at this point is we've fed Rover this APK file. We provided basic authentication information. Rover, which is essentially a step generator, this bot, it functions like a human being. It knows what a gesture is, it knows what a swipe is, it knows what a long press is. So it implements all the tools that it has, and then it basically uses the philosophy of explore and exploit, and it clicks through the entire application. And while it clicks through the entire application, number one, it's plotting it And number two, it's identifying all the different screens, and it's identifying all the different states of transition. Right? So if I were to get to the next screen, essentially the reports that we will get from this is everything from what type of devices is the app running on, when, how long did this program run or the bot run, the start time, the end time, the name of the application, and a number of other things. But more importantly, it'll also tell you things like CPU usage. It'll plot this graph on the right-hand side where you can spot problems in CPU usage or memory leaks or any of those things. It'll tell you the network usage. It'll tell you how much RAM was utilized. Essentially, it's doing two things at the same time. It's doing functional testing and performance testing in parallel for you, right? So it's your classic exploratory testing. What Rover will also output is all the screens that it encounters along the way. And it'll give you all the ID values for every screen that it encounters along the way. This is useful because it tells you the actual sequence of the flow, and everything's enlarged, so you know where the problem statements are. And if you click on any one of those nodes, it'll automatically give you a highlighted, larger image that you can again use for all kinds of validation. And perhaps most importantly is this thing called the adjacency matrix, and more importantly is sort of the adjacency matrix will essentially allow you to spot transitions from one screen to another, so you know which screen is coming up next. Where that becomes useful is when we start automatically building tests. So in this particular case, what we've done is we've used the transition graph or the transition diagram. Assume for a moment that we've identified some problem statements because there are some missing screens or there's some certain types of errors in this overall flow. What we can do is start building an automation script right from this graph. So out here where there's a green circle, that's the starting point for the test script. The red circle right above that is the ending point for that test script. The red square is the last screen of the exploration, and all the blue screens, all the blue circles rather, are the different points that you've clicked on to essentially build the script that's highlighted on the right-hand side over here. So from our standpoint, this bot is the fastest way to test any kind of mobile application before you push it out. It's also the fastest way and the cleanest, most codeless way to build automation scripts as well. I mean, both those things have come together in one single bot. Okay. And then this last screen essentially shows you what that the output will look like. So this is where once you say export script, you're now creating an automation script that you can store and run anytime, anywhere. But again, like I said, it's probably the fastest way in which you can build a mobile automation script. So if that's the basic idea of Rover, from our standpoint, there are a number of different things that it'll find along the way. It'll find errors, like I said, it'll find memory utilization challenges, CPU utilization, it'll find broken links, and it'll also give you information about how many screens, how many actions, how many transitions, and this is a real example that we did for our client. So again, it's the most efficient way to do both these types of testing in one shot. And overall, we continue to believe that it's the fastest way to test mobile applications. So I know we're kind of running close on time. So I want to close at least my section with this. From our standpoint, the questions that we keep asking ourselves are, how do you enhance software test automation? That's a relatively basic question now. More importantly, to the points that Diego made early on, how do you deploy AI augmented testing? How do you go from the augment mode to the full autonomous mode? And perhaps more importantly, are we at a point where we can move to the next paradigm where we can completely eliminate the idea of looking for elements and finding locators and things like that to build tests? We believe we're close to that. We have a solution for that. But most of all, how do you infuse an autonomous bot with the qualities of the most creative set of testers so that you can remove the mundane, repetitive tasks, which are important for everything that's happening in the Agile marketplace, but are nonetheless certainly difficult to implement at scale. Right? So those are the big problems that we're trying to solve at Qyrus. Okay. So with that, I'm going to pause for a moment. I think there's one important question that came through from the team, even though we're a few minutes beyond 11. I'm going to send this question to Diego. So Diego, the question is, it's often difficult for business leaders to justify the cost of testing. And by the cost of testing. So do you have any recommendations for our audience in terms of how you can have that conversation with the leadership?
Well, I think the short answer is that this shouldn't happen in a vacuum, right? Testing is part. Every organization is trying to accelerate, to transform with digital. Part of that transformation is modernizing the way they build software, and testing can't remain the old way, right? So the budget has to be found in when they're thinking about the digital transformation and the modernization of the development. They also have to think about the modernization of testing, because it doesn't matter if they build cool, creative new applications on mobile if these mobile apps don't work and get 1, 2, 3 stars. And it's about I think that the discussion to have is, it's not just about fast, it's about being, we can still be fast, but we want to also make sure that there's quality there. I think you just have to sit down and kind of explain really what the risks are of not doing the testing on one side, and that modernizing if you're modernizing development, which probably many organizations are, or trying to get faster software deployed, it can't come at the risk of quality. That's today digital, everything is digital, software is everywhere, and therefore when these problems happen, they're very visible to the market, right? And so it really hurts the brand. It means missing a lot of revenue, and that's much bigger than the investments that need to be made in testing. Those are some of the arguments I would use.
Thank you, Diego. That's very helpful. I'm just going to take one high-level question that was sent to me. Is the platform currently available, and can we test drive it? The short answer is yes. The Qyrus platform is available for all things web, all things mobile, and all things API. And like I mentioned, we can also do the component testing, which essentially integrates web, mobile APIs all together. But more importantly, since we're focused on AI today, everything that we shared today, as rushed as it was, all of those things are available, and they're available to test drive, they're available to pilot. And for those of you whoever sent the question, if you're interested in running a pilot, we're happy to help you with that. We're also happy to help you with a client success team, which is essentially a Chicago-based team that will assist with all the mechanics of setting up the pilot and walking you through the app and things of that sort. But the short answer is everything's available. And for those who are interested in sort of testing chat bots, so what we used today in Qyrus bot was the idea of chatting with a bot and generating tests. But what if you want to test the chat bot itself? I mean, that's the other feature that we've recently built. And if folks want to test chatbots or test AI using AI, we're very happy to have that conversation as well. So with that, I'm being urged to bring this conversation to a close. For the audience, thank you very much for attending. And Diego, thank you very much for all your insights.